about is the chemical properties, or we can say the reactions of alkane. First of all, I hope you know that alkanes are saturated. I hope you understand that. Why do we say alkanes are saturated? Alkanes are saturated because they have a carbon to carbon what? Single bond. The carbon to carbon connection is a single bond, and single bonds are said to be what? Saturated. They are saturated with what? Hydrogens. Okay, so now alkane being saturated it doesn't really like reactions, sort of, but if being forced and under the right condition, alkanes can undergo two major or two main reactions. One is combustion reaction, that is reaction with oxygen, incomplete and complete combustion. We'll start from there. So the number one reaction of alkane, or the number one chemical property of alkane, is reaction, or you can say combustion reaction. Okay, talk about combustion reaction. That's number one. Now, what is combustion reaction? Combustion reaction is simply the reaction of an alkane with oxygen either in excess or insufficient to form a product. Okay, now if an alkane or a hydrocarbon reacts with oxygen in excess, okay, in excess, this is called the complete combustion. The product of this combustion, no matter the alkane, is CO2 plus water. But if the alkane undergoes combustion reaction with this guy being insufficient, okay, being insufficient, that is not enough. The product of the reaction is carbon monoxide plus water. So when you can be able to write this equation, then you can now balance it and get the complete equation for combustion. For example, if methane reacts with oxygen, it will give us CO2 plus water for complete combustion. That is, if this one is in excess. Okay, if this guy is in excess, if it's a complete combustion, if it's a complete combustion, we are going to have this. So is the equation balanced? No, we can balance it. Carbon is 1, carbon is 1. Hydrogen is 4. We put 2 here to balance 4 hydrogen. Oxygen is 2. We have 2 plus 2, which is 4. So I'll put 2 here. So this is a complete combustion of methane. Let's use another compound. Let's use maybe butane. Butane is C4H10. If you undergo complete combustion with oxygen, you have CO2 plus water. Is the equation balanced? No. Let's balance it. I have 4 carbon. I have 4 carbon here. I have 10 hydrogen. I have 5. 5 times 2 is 10. So I have 4 times 2, 8. 8 oxygen here plus 5 is 13. So to balance it, I will simply put 13 over 2 here. Why did I put 13 over 2? I have 13 oxygen here, and I want to balance 13 oxygen here. What I need to, but remember, I have what I need to put here to make it 13. If I put 6 times 2 is 12. If I put 7 times 2 is 14. So what needs to be here is 6.5. 6.5 times 2 will give you this 13 oxygen that is here. That is 4 times 2, 8 plus 5. So total oxygen here is 13. But total oxygen here, if I put 6.5 here times 2 is 13. And 6.5 is the same thing as 6 whole number 1 over 2, which is 13 over 2. That's how I got 13 over 2. So what should be here is 13 over 2. Okay? Because 13 over 2 is 6.5. 6.5 times 2 is 13. Okay? So we have this. Now, you can balance the equation no matter the hydrocarbon. Okay? If the alkane is propane, butane, or any alkane, you should be able to write and balance a complete combustion reaction of any alkane. Now, this particular reaction I've done is one of the simplest reaction of alkane. Now, the main reaction of alkane is substitution reaction. Now, what is substitution reaction? Substitution reaction simply means replacement. replacing an atom in a molecule in an organic compound with another atom in a molecule. Okay, so now the key reaction of alkane is substitution reaction. Why? Because they are what? Saturated. And the particular substitution reaction that alkanes undergo, the number one, or the first one I'll talk about, is halogenation. Halogenation simply means replacing one of the hydrogens from an alkane. Halogenation simply means replacing one of the hydrogens from an alkane with a halogen, okay, to form arrow X plus HX. Look at what happened here. X is the halogen. H is the H in the alkane. Okay, this is an alkane. How did I get R? Remember that CnH2n plus 1 dot H is also alkane. So where this is equal to R. So this plus H. So X is the halogen. This is the halogen. So X will replace this hydrogen, and the hydrogen will now pick up the remaining X here to form HX. Okay? So this reaction takes place in the presence of UV light. So there must be a UV light, okay, to catalyze this reaction. Okay? So now, let's look at a simple halogenation reaction. The halogenation reaction we're going to consider now is chlorination. Chlorination simply means reaction of an alkane with chlorine. Now, how does the reaction go? If I have my alkane, which is this, for example, plus chlorine, this reaction takes place in the presence of UV light. Okay? So what is the essence of the UV light? The UV light, the job of the UV light is to initiate the formation of a free radical. Now, this UV light will initiate the formation of this free radical. The free radical, which is the chlorine radical, will now, very, very reactive, will now propagate this alkane and then form the desired product. So in this reaction, this free radical, which is formed as a result of homolytic bond breaking, will propagate with the alkane. So I will have RCl plus HCl. This reaction will stop here if the chlorine is in excess. Sorry, if the alkane is in excess, or if the chlorine is insufficient. But if the chlorine is in excess, the halogenation or the chlorination will keep happening until all the hydrogens in the alkane is replaced. For example, watch. If I have methane reacting with chlorine, UV light. Okay, what happens here is the chlorine free radical will substitute the hydrogen here. So I'll have CH3Cl plus HCl, right? So this reaction will stop here if the chlorine is insufficient or if the methane is in excess. Okay, so but if the chlorine is in excess, the halogenation will keep happening. Okay, for example, if I'm reacting this UV light, okay, the halogenation will keep happening until the chlorine has replaced all the hydrogen. And anytime chlorine replaces all this hydrogen, what I will have here is CCl4 plus HCl. Now, how many chlorine was used for this halogenation? I have 4 of it here. So it means that to balance this equation, here should be 2. Okay? And how many hydrogens do we use? Hydrogen here is 4. So I'm going to have 4 hydrogen here. Okay? So the chlorine has increased actually from 4 and 4 here, 8. So what should be here is actually 4. So 4 times 2 is 8. So I have 8 chlorine that was able to replace this guy, because I have Cl4 and 4Cl. So the equation is balanced now, right? So I have 1 carbon, I have 1 carbon here. I have 4 hydrogen here, I have 4 hydrogen here. Then I have 4 times 2, 8. I have 4 chlorine and another 4 chlorine here. So this is a balanced equation. So 4 times 2 is 8. It's balanced. So now, so what I have here is called tetrachloromethane. chloromethane is the end product of chlorination of alkane, of this methane. So this is the product of this reaction if chlorine is in excess. If chlorine is in excess, right? So this is the equation for this reaction. So now, there are more examples we can use concerning this chlorination reaction. We can use bromine. If it's bromine, it's called bromination. So this reaction is what we call substitution reaction. And the mechanism of this reaction is it follows a free radical mechanism, which involves 3 stages. The 3 stages are initiation, propagation, and termination. Initiation is when this chlorine will break up to form the free radicals. Propagation is when the chlorine will attack the alkane. Termination is when the free radicals will terminate themselves so that they can become what? Because these free radicals are very reactive. So if they don't terminate, the reaction will keep going, even if you don't want it to continue. So for the reaction to stop, the radicals will find a way to terminate so that the reaction can come to an end or to come to completion. So this is the mechanism. So I'm not going to go into details of this mechanism. Just know that these 3 mechanisms, these 3 steps are the steps taken in halogenation or chlorination of an alkane.